Okay, question 12. Only a couple more to do. So, question 12, what's the internal force in member CE? So CE is this thing down here. Now, we found this internal force here using method joints and this one here using method joints. There could be an argument of maybe, and this AC would be quite easy to find as well, that we could march along and use method joints here. But the question will be worded in the exam paper specifically to use method of sections. So you want to try and find your CE internal force here using method of sections. So pause the video, give that a go, see if you can try and get one of these. And once you're ready, watch my solution. So I'm going to do method of sections through here. I found that this force here is 16.7 or 16.777, 16.666 rather, but that would be good enough, I guess. Right, so we'll keep the left hand side because I haven't bothered working out what the reaction is on this G point here, so I don't know what that is anyhow. So keep this bit of framework, draw yourself a new framework diagram. Make sure you include all the external forces. We've got a 20 there. You can draw in the framework, although it's not going to affect anything. 16.7. The only thing that's of interest is the cut through members which are exposing their internal forces. Okay, that's not brilliantly drawn, so let's move that. I'll remove that so it's not so confusing. Right, so this is internal force CE, this is internal force DE, this is internal force DF. A lot of questions usually are find what DE is, and what you want to do there is resolve in the Y direction or something of that ilk. Here, that's not an option. Resolving forces in the Y direction, then the X direction could be a way to go, but what's most obvious thing to do is get rid of these two unknowns by taking moments about that particular joint. And also, that's nice actually, also notice that if we take moments about that particular joint, then this force, the external force, also goes. So it becomes quite straightforward. So let's take moments about here. We'll go clockwise. So from here to here is how much? 6 meters. Taking moments at D. So it's going in the wrong direction of my arrow. So that would be minus 6 times CE. This one here is actually going in the right direction of my arrow. So what's the distance from here to here? I'm going to transpose this force. Imagine it flies up to this point here. And then it's giving me a nice right angle. And it's 6 again. So that's straightforward. So plus 16.7 times by 6. So we don't need the 6's. So we can see that the CE will become positive, isn't it? So it's positive 16.7. Get rid of the factor 6. So it's positive, so it's attention. So we're looking for a positive 16.7, please. So hopefully you selected option number 4.